OK, so how would we do this construction of sigma if we didn't know about this linear sigma model way of getting there? So we have a generator G, which is in L comma R. That's my notation for the combined SU2 left cross SU2 right, for example. And that's going to be broken down to something that's in the vector subgroup, which I'll denote like this, V comma V. And then an element of that we can call H. And if we want to parameterize the coset, you can think that you have a G left and a G right in a kind of obvious notation. And you want some kind of field to parameterize fluctuations where we pull out the H. So I'll call that cascade. So let's just think about an example. So say we had something that looked like this, which is some set of generators that is in the original L comma R. And let me insert in here 1 in the form of GR dagger. And then write it as a product of generators that looks like this. So I'll just multiply the various, this guy multiplies that guy, this guy multiplies that guy. So this guy here has the same entries in both, so that's in H. Okay, this is in the V comma V, which is H. And this guy here, this GR dagger, is then the thing that's parameterizing the cascade field. So this is a matrix that's parameterizing the coset. And transforms in the way that we said. Okay, so that's the idea behind what the sigma field is doing. Now you can ask, well, that just seems like one choice, and I could think about parameterizing the coset in many different ways, and that's true. And there's actually a nice formalism that takes that into account. So if you just talk about broken generators, which I can call X, then a very general definition of what this cascade field is just an exponential involving those broken generators and some fields to describe the fluctuations and normalized in some way. And this is due to Callan, Coleman, West, and Zamino. So it's the CCWZ prescription for parameterizing the coset. And the point of their prescription is that you have choices here for how you represent the broken generators. Start out with left generators and right generators, and then you go over to the vector generators. But what ones are broken? Well, you could take different linear combinations that are broken, and those would be equally viable choices. It doesn't have to be a group, the broken generators. So you can pick different choices of this X. And if we pick X, which is the left generators, that's what gives us, that's actually what gives us what we were talking about before, because then we end up parameterizing that we end up parameterizing the cosets by something that has 1 in this second entry because we don't have the right. We're just saying pick the left. The left are broken, one possible choice. Left plus right is unbroken. Then we end up with an entry here, which is sigma. That's our sigma. And if you work out in this, also if you work out the transformation, how the sigma transforms, you could reproduce. You can also derive that sigma goes to L, sigma R dagger. But that's just one choice. You could do other choices. So for example, you could pick XA to be tau left A minus tau right A. That's another possible choice. And that would lead to a different field. But an equally valid parameterization of the coset. And this was actually also popular. At least it's something that people usually denote by C. And I'm going to leave further discussion of that to your reading. There's a very nice review by Anish Manohar where he goes through some of these things for CCSW. And he does a nice job of talking about both of these in more detail than I've done here. OK, so that further discussion of this point will be in your reading. You can also look back at the original paper if you like, but Anish has distilled it nicely. OK. So any questions about that? There's a way of thinking. I'll just keep talking until someone raises their hand. There's a way of thinking about field redefinitions even from this low energy point of view. That's the key here. And it has to do with the freedom that you have and how you parameterize the coset.